Hello folks, how's it going? This is Mike coming back at you with another video on Foundations of Math 2. In this video, we are going to begin our discussion on logic, logical forms, logical statements, logical connectors, and many other fun things. But I want to kick it off by talking about a specific word and its meaning in everyday conversation versus its mathematical meaning. So in everyday English, a statement is a sentence, and the content of this statement, or of this sentence, I should say, doesn't necessarily have to be true or false. It could be a very subjective statement, and whether you think it's true or false is based on your personal beliefs, thoughts, whatever. But in mathematics, when we talk about a statement, we're talking about a sentence that can objectively be determined to be true or false. It can't be both, and it can't be neither. But it is a statement that is easy to tell it's true or it's false. Some examples of bad statements, things we don't want to work with in the world of mathematics. An example is Joe Biden is a bad presidential candidate. That is a very subjective statement. That is a very subjective sentence that is all based on your personal political views. An example of a statement or sentence that is something we would want to work with would be the wall is painted solid blue. You look at a wall, it's either painted completely blue or it's not. Objectively true or false, no question that can be raised. So a statement like our previous examples are known as simple statements. There's only one main idea happening there. But we can take two or more simple statements and we can combine them in some fashion and we can make what's known as a compound statement. For example, I am over 6 feet tall and I weigh less than 200 pounds. If I take a look at this statement right here, namely this compound statement, we see that there are two simple statements making up this thing. There's I am over 6 feet tall. That can objectively be made true or false. And then I weigh less than 200 pounds. That can objectively be made true or false. Another example, if the sky is green, then pigs are purple. Once again, we have two simple statements there, each one objectively determined to be true or false. And there are four main ways that we will see that we can connect these simple statements. First way is with a disjunction. You have your two simple statements here, and you connect them with the or. As an example, I am a male or I am a female. There are your underlined pieces there. Each singular ideas, singular statements, objectively true or false, with the or in the middle. Another example is the conjunction. Instead of connecting two simple statements with an or, we're connecting two simple statements with an and. One example of this is I have been to Canada and I bought a toque. You've either been to Canada or you haven't, and you've either bought a toque or you haven't. The third way we can do this is with a conditional statement. If blank, then blank. If first simple statement, then second simple statement. The other way that you can write this is blank if blank. And what would be going here is your second simple statement. Whatever was here would go there, and whatever was here would be going over here. So I used rectangles and stars to symbolize what would be going where in the corresponding forms. How you would write this, an example is, if I punch you, then you will cry. Either I punch you or I don't punch you, and either you will cry or you won't cry. The other way you could state this using this alternate form here is, you will cry if I punch you. And the fourth and final way that we mainly connect these simple statements is with the biconditional, or a biconditional statement. We have our two simple statements here, and in the middle we have if and only if. This is a fancier, more mathematical way of basically saying the two things are equal in some kind of sense. An example of this is, the Bills will win if and only if they wear blue. Either the Bills win or they don't, and either the Bills wear blue or they don't. Again, two simple statements, objectively true or false on their own, connected by the if and only if. Here I'm going to give you a couple sample problems. Try to figure out what connector is being used in these two samples here. So you will get $20 if you clean the kitchen. And the second one, we are not buying lunch and you will starve. So pause the video here. Try to figure out what logical connectors are being used in each of these two sentences here. So press pause. Once you think you have the answers, press play, and we'll see if your answers were correct. All right, so let's see if your answers were correct. Hopefully for the first one, you found that it was a conditional statement. You will get $20 is a simple statement on its own. And then you have you clean the kitchen is the other simple statement in here. And we have the if going there. Not the if and only if, just the if. And that's your sort of key, that's sort of your trigger word of, okay, conditional. And for the second one, hopefully you got a conjunction. We are not buying lunch, and you will not starve. Two separate ideas, two separate simple statements with the and in the middle. There is a fifth operation, not so much a logical connector, but an operation more that we can do with simple and with compound statements. Again, two or more are not required. We can do this with any number of statements here. And it is the negation. The negation of a simple or compound statement is simply going to give us the opposite of what the statement itself was. And if the given statement, whether simple or compound, was true, the negation will be false. If the given statement was false, then the negation will be true. So taking the negative just switches the truth value. And that two-word phrase, truth value, we're going to be seeing that coming up a lot in the near future. The negation works exactly how you might think. For example, the negation of the statement, he is 60 years old, is he is not 60 years old. It is literally just adding the word not in there and adding it in a spot so where the sentence reads sensibly. When we work with simple statements or compound statements, for the most part though, compound statements, we're more concerned about the form of the statement. We're more concerned about the logical form that's happening in there, not so much the actual content of the statement. We are concerned about the content up to a certain point. We're concerned that the content can objectively be determined to be true or false, but once that's been shown or verified, we don't care about the content after that. So typically we use letters to take the places of the simple statements within the compound statement to make things nicer and easier to work with. The three most common letters that we use are P, Q, and R. Technically, you could use whatever letter you wanted, but ultimately, it doesn't really matter. And for each of those logical connectors that we talked about earlier, the disjunction, conjunction, conditional, and biconditional, we have symbols for each of these guys. We have a symbol for the negation as well. It is the tilde, or the one that you'll see me use more often is this guy right here. It's a horizontal dash and then a little vertical line going underneath. The symbol for the disjunction, it looks like a V. The symbol for the conjunction looks like an upside down V or a caret. The symbol for the conditional is a right pointing arrow. And the symbol for the biconditional is a left and right pointing arrow. So it's going to be important to be able to take a given sentence and write it in its logical forms or a logical form using letters and logical connectors, as well as vice versa. Taking a logical form given to you in letters and connectors and writing it as a sentence. So here, let P equal I have blue hair, and let Q equal my brother is 40 years old. Take each of the following sentences and write it as a logical form. The first one here, I have blue hair, and my brother is not 40 years old. So if we take a look at this sentence and we just underline some key pieces here, things that look like what we're given in the statement of the problem, we see that we have our two simple statements, something with blue hair and something with my brother being 40 years old. And there's the word and in the middle there. The fact that there's an and in the middle of those two simple statements tells me that we're going to be using the conjunction in some way, shape, or form. So we're going to use that upside down V or the caret symbol to represent the conjunction. Now, before the conjunction, I have blue hair. That is exactly what P is. So I have P and. Now here, this says my brother is not 40 years old. Well, Q was my brother is 40 years old. So what we have right here is not Q. So what I am going to be writing here is P and not Q. Now, as a quick note, you can see that I put parentheses around the not Q. Technically, I didn't have to do this if that not symbol is only going on one letter, then the parentheses are not needed. But if you're going to take the negation of several things like not the quantity P and Q, then you want to put parentheses around everything that you're taking the negation of. So if you're taking the negative of just one thing of one letter, and there's no other symbols involved in what you want to take the negation of, parentheses not needed in any way, shape, or form. If you want to take the negation of many things or many combinations of things, everything that you want to take the negation of, put parentheses on it, and then put this sign out in front of those parentheses. Try this next one on your own. My brother is 40 years old if and only if I do not have blue hair. Try to write the logical form for this guy on your own. So press pause. When you think you have the answer, press play, and we'll see if you are correct. So hopefully as your answer, you got Q if and only if, not P. We have the two simple ideas there, the two simple statements with an if and only if in the middle. That phrase should be your mental trigger for the biconditional. We had my brother is 40 years old right before that, if and only if. That's exactly what Q was. And then we had, after that, I do not have blue hair. Well, I have blue hair was P, therefore I do not have blue hair is not P. So that's how we take a given sentence and write it as a logical form. Now we are going to go the opposite way. We're going to be given a logical form and we want to write it as a sentence. So first one, Q implies P. Well, we know that the conditional means if blank, then blank. So Q implies P means if Q, then P. We know what Q is. We know what P is. So let's just make the actual substitution and we get our sentence. If my brother is 40 years old, then I have blue hair. So we are good right there. Try the next one on your own. Try to see if you can write this logical form as a sentence, not P or Q. So press pause. When you think you have the answer, press play, and let's see if you were correctamundo. Right, so hopefully you got this as your answer. Hopefully you got, I don't have blue hair, or my brother is 40 years old. We take the negation of P, and we take Q, and we put the word or in the middle of those two guys. So these are our sample problems going between sentences and logical forms. Very important to know how to do both. Sometimes with simple statements or with compound statements, we can put these guys in the context of a set or a group or a collection of some kind of object or some particular objects. And the statement may be true or false based on how many elements of the set or how many things in that group we claim. We could claim some of these objects have something true or have some property, or we could claim that all of the objects in a set have some property or something like that. And when we create statements like this, when we're bringing in a quantity of things, we are using quantifying words or quantifiers to throw in the mix with our simple or compound statements. Typically, if we are going to talk about all elements of a set or all the things in some kind of group, typically we will use words like every or all, or we'll use the phrase for all. There is a symbol that we use in math to represent words or phrases like this, and the best way to describe it is that it's an upside down capital A. If we were only talking about some elements or just one element of a set, words we would typically use are things like there exists, there is, or some. We have a symbol for this kind of case where we're talking about only one element or some elements, and the best way to describe that guy is that it is a backwards capital E. So here are some examples of quantified statements, and we're going to see whether or not these are true or false. So first one, all dogs have 4 legs. So this statement is true only if every dog out there, every dog in the world has 4 legs. Now, granted, do we know every dog in the world? No. But is it reasonable to think or reasonable to assume that somewhere out there is a dog, that either wasn't born without a leg or 2 legs or had to have a leg amputated? Some of you may have such a dog, or I can probably go online and search for a picture of a dog that doesn't have 4 legs. So I think it's reasonable to think and reasonable to assume that not all dogs have 4 legs. Therefore, this quantified statement here is false. Next one, some motorcycles are colored red, or just some motorcycles are red. This is true if there's at least one motorcycle out there that is colored red. Again, do we know every motorcycle in the world? No, but I know of someone personally who does have a red motorcycle. So there is at least one motorcycle out there that is colored red. Therefore, this is a true quantified statement. Third one, I think people will have fewer questions on. Every physician is a human being. So if we were to look at the set of all physicians out there, is every single one of them a human being? Well, unless you have some knowledge that I don't have, or you are taking some kind of drugs or medication that I am not aware of, that make you think something else. Last time I knew, all physicians are human beings. I don't think there are any aliens trying to pose as human doctors. So we can reasonably assume that every physician is indeed a human being. And this quantified statement is true. And last example I have here, there is an albino alligator. So again, we see that phrase there is, implying that there has to be just some or one albino alligator. Not every alligator out there has to be an albino one. And as a matter of fact, there is an albino alligator out there right now. You can verify for yourself. So this quantified statement is true. Now, again, the main focus here is not so much the actual content of these simple quantified statements here. What I'm really trying to get you to see more is the idea of certain key words or key phrases will need to trigger certain things in your mind to help you figure out whether or not something is true or false. If you're seeing words like for all or every or all, everything in that group has to have the particular property for that to be true. If you're seeing words like some or there exists or there is, then at least one thing in that set or at least one thing in that group of objects has to make the property true for the entire statement to be true. These were all simple compound statements. An example of these were all simple quantified statements. An example of a compound quantified statement would be all cars are 6 feet tall or have 5 wheels. We have that quantifying word of all. And then we had all cars are 6 feet tall. So the car is 6 feet tall or it's not 6 feet tall. That's one simple statement. And then we had weighs 200 pounds, or weighs or has 5 wheels. Pardon me, guys, it's late here. And that is objectively true or false. Those simple statements were compounded by the or, so we had the disjunction happening there. So that is an example of a compound quantified statement. So this wraps up our video on our intro to logic. Logic forms, logical statements, logical connectors, quantifiers, and writing sentences as logical forms and vice versa. If you have any questions or comments, please be sure to reach out to me, guys. Email, text, phone call, snail mail, emergency flares, magic wands, messages on blimps, whatever you have to do. Otherwise, until the next video, take it easy, folks.